Lesson 24, returning to hyperbolas. We're talking about the equation, the generic equation in this case. Now, the generic equation for a hyperbola is actually going to be very, very similar to that of an ellipse. Now, remember the ellipse was x minus some h squared divided by a squared. And then we had a plus sign. But now with the equation for the hyperbola, there's a minus sign here. Let me refocus this. Okay, so with the ellipse we had the addition, with the hyperbola we're going to have the subtraction. So I'm going to have a subtraction sign here of y minus k squared divided by b, sorry, this would be a squared, this would be b squared, is equal to 1. So this is the equation. Now, how do the vertices, the foci, the transverse axes, and the conjugate axes actually work? Well, notice where I have the negative sign. Okay, now let's talk about this graph up here real quick. Okay, this is very important for us to understand. If x is 0, let's assume that x is 0. Remember, a is just a constant, so it's going to be 0 over a number. That whole thing is going to turn to 0. Then I have this thing. Is it possible for me to have negative something squared equal to a positive 1? Again, ask yourself that question. Is it possible for me to have negative something squared equal to a positive 1? And the answer should be no. This shouldn't make any sense. What I'm trying to say then is that it is never possible for that x value to be 0. Which makes sense that if my negative is on the y, it's in the y direction that I have all this empty space that's unused. Again, if my negative is with the y, then my conjugate axis will be vertical and my transverse axis will be based on the x-axis. Okay, so with this particular equation, what I'm going to see, and I'm going to go ahead and draw it to the best of my ability such that I go over h and then up k. That's the so-called center, where it's really just the intersection of the conjugate axis, such that the point at the top of the conjugate axis is h comma k plus b, and this is going to be h comma k minus the b value. Notice the b value sitting here. Again, those 2 points are theoretically completely unimportant, okay? But there is a good need for them. There is a helpful use to them, okay? And we will get to that here shortly. Next thing is, where is the transverse axis? Well, the transverse axis is going to cut through here. Okay, and those 2 points right there would be actually my vertices. Now, where are those vertices going to sit? Well, I'm going to go over h up k, but then I'm going to go over an extra value. What's that extra value? Well, it's going to be the h plus a comma k, and over here is h minus a comma k. Again, very, very similar to that of the ellipse, where the h is the center and the k is the center, the intersection of those two cross lines. And then a is going to be the shift over left or right because it's with the x, and b is with the shift up or down in terms of the y because it's with the y. Now, how does our hyperbola really look? Well, I'm going to go ahead and, before I get too far ahead, let me label my vertices. My vertices will be, my vertices will be the h plus a comma k and the h minus a comma k. So, where specifically then would my foci be? Well, if these are the endpoints of my transverse axes, then the graph should pass through those points similar to this. Okay, and my foci should be somewhere out here. Somewhere. I don't know exactly where, but where would they be? Well, just like up here, when I had c squared was equal to a squared minus b squared, with this, I told you there's a plus sign here, so I should have a minus sign here. The hyperbola is actually c squared is equal to a squared plus b squared. So now what I'm going to find is I'm going to be able to find my c value based on the hyperbola with this a and this b value. Once I found that, my foci are actually going to be up to h, over to h, up to k, and then over a value of c, and then over a negative value of c. So my foci are actually going to be h minus or plus c comma k, and h minus c comma k. Notice the difference between this one here and the situation that we had up here. The biggest difference is the fact that my foci should be on the outsides, way out here of those vertices. Whereas if they were inside, which is where this minus sign would help us situate them inside, the plus sign helps us situate them outside. And now this thing, again, rotates around that foci with a certain, if you learned from the last video, eccentricity. Okay, the last piece to worry about, okay, is how do these particular pieces behave? Well, there's something actually very cool about this and the way it works. I'm going to get out my red pen for this, okay, so you see it a little bit better, is we need to know where asymptotes are sitting. Okay, where are the asymptotes sitting? Now, the graphical way to develop this is where those points are. Create myself a little rectangle here. I'm going to zoom in so you can see it a little bit better. Okay, I'm going to create myself a little rectangle here. Now, in terms of this rectangle, we have a point in the center, okay, and we have a point up here. We have a point down here. Those 3 points together create a straight line. That straight line is the asymptote for this hyperbola. We also have one in the opposite direction, passing through, again, that corner point, that center, and then this corner point. So I've drawn this hyperbola definitely wrong. So it would be better for me to draw my asymptotes before I draw the actual hyperbola, because those asymptotes sit very nicely this way. Now, how can I generalize this to be able to find those lines without having to find this point, this point, this point? It gets a lot of work to find all those different points, just like this point, and this point. It's not worth the time, okay? We're lazy. Let's find this asymptote based on a simple formula, okay? And it will always be the same set of formulas, okay? Honestly, the always same set of formulas. If my transverse axis is in terms of the x values, okay, the larger value, because, you know, a negative value is, well, smaller than a positive value, then my asymptote will always be y minus k equals to plus or minus b over a times x minus h. Okay, again, the larger value, the positive value on the bottom here. This is the slope. It's the change in, again, notice the change in the x-coordinate in terms of the y-coordinate. So I'm going up y, rise b, run a, b over a, b over a, b over a, rise over run. If this was facing the opposite direction, I'd have rise over run in a similar fashion. Okay, but then my a value would be over the y's here and not over this one. Again, because we're going to keep this formula and the fact that the positive value is going to come first. Again, the positive value is going to come first. So notice again why the h and k are there. The h and k are there specifically to shift the center point, the starting point, to be there. And then we're going to go up b over a, up b over a. So that's the setup for a hyperbola that's got the transverse axis in terms of x. Well, what if I had the transverse axis in terms of y? Well, the equation would only change slightly. The equation would change to be my y minus k squared divided by a squared minus my x minus h squared divided by b squared equals to 1. Now, you can do this however you want. I really don't care, as long as you understand that the positive term we're going to put first, okay? And the negative term would come second. Notice the positive term is under the y, so that means my transverse axis, okay, my transverse axis will be in terms of the y-axis. So, where this graph over here had the transverse axis in terms of x, because the positive was the x, this one's going to have the transverse axis with the y. So, if I were to draw this one, I'd see the transverse axis go here to here, the center would be somewhere in here, I'd have my conjugate axis be from here to here in some way, and then I would have, again, I'm going to go ahead and draw this in red, so it looks very similar. I'd have my asymptotes there, and there. And my graph would be coming out of this point, approaching those asymptotes here, and out of this point, approaching those asymptotes here. Okay? This would be the graph that corresponds to this, where how everything changes, the vertices would be h over h up to k, and then I'd add or subtract the a value, because the a value is what's under y. So it's plus a, or h comma k minus a. My foci would very simply be h comma, now my foci are going to be up here somewhere and down here somewhere. Again, up here somewhere and down here somewhere. So I'm going to go over to h, up to k, and I'm going to either add the value of c or subtract the value of c. Again, I don't see these things in terms of these formulas. I actually look at the graph and I go, I know where everything's supposed to sit. That's what I'm going to remember. But if you want to memorize these formulas and how to use them, that's perfectly fine with me. The last piece is the asymptotes. Now notice with the asymptotes on this one, I would have y minus k is equal to some value x minus h. And what's the value here? Well, what's the rise over the run this time? From this point, the rise would be an a value. The run would be a b value. Again, up a over b, because a is with the y, b is with the x. So it would be a y's divided by b x. Okay? And this would be a plus or minus for that, because I'd have the positive slope and then the negative slope. Again, up here, why it's plus or minus, it's the positive slope of that and the negative slope of that. That covers the generic formulas for the hyperbolas and all of their information. Okay, make sure this is somewhere written down. Yes, it is on this handy dandy little formula sheet. Okay, and you will see all the information here. But honestly, I wouldn't focus on this. I would try and remember these images that are on this paper. They'll help, okay, on how they see. The next video we will cover how to graph these things, finding all the information.